So today we're going to be doing countEvens. So it says return the number of even integers in the given array. Note that the mod operator computes the remainder. So 5 mod 2 is 1. So the modulo operator actually only returns the remainder instead of the answer of the division problem itself. So essentially what we're going to do is we're going to first understand that if we have any number mod 2 reap a 0, then that would essentially imply that that is an even number because it's divisible by 2 completely. And so that is sort of our metric to really judge whether or not a number is even or not. So if that number mod 2 reaps 0, or if that number divided by 2 does not have a remainder, then we can assume that that number is even. So first and foremost, it's telling us to essentially return the number of even integers. And so we want to, when we're returning something, it would make most sense to store that something in a variable so that we can later on use the return keyword and actually return that variable back. So for this one, since we're dealing with integers, we're going to have a variable called count, which is going to store the number of even integers in the array. And the plan is to increment count if there is an even number. So the idea is we really want to evaluate each and every number in the array. So what we're going to do in this case is we are going to use a for loop. And of course, the for loop has 3 parts, where we say that int I is equal to 0, I is less than nums.length, or the name of the array .length, and then we increment I by 1. And essentially what that means is we're keeping track of the index. So I is really representative of the index itself as we move through the array. I must be less than nums.length because the number of indexes in the array is actually one less than the length of the array itself. And so if I is less than nums.length, or in other words, if the index number is less than the length of the array, then as it increments starting from 0, we will ensure that we don't actually walk off the edge of the array such that we get an out of bounds index error. So this is us traversing through the array. So essentially what we do is we use an if statement, right? We can say, well, if any given element in the array, and this is how we actually designate that, if we wanted to reference the first, if we want to reference the element at the first index, we would do 1. If we wanted to reference the element at the third index, we would do 3. And likewise, any number in this box would sort of symbolize the index that we're on, and it would start evaluating that particular element at that index. So I really represents any particular element or index at or an element which is referenced by an index, because it starts from 0, it starts counting up. So as we traverse through the array, I is essentially going to assume a new value. For the first iteration, it'll be 0. So we'd be looking at the 0th index, which would of course give us access to the first element. And as we iterate through, in other words, as I is incremented, it becomes 1, 2, and 3. And so now we're sort of looking at new elements as we move forward, as the executions continue. So if any given element at a particular index modulus 2 is equal to 0, then we'd know that that number is even. That's sort of our metric here for deciding whether or not a number is even. That number mod 2, if it's equal to 0, in other words, it has no remainder, then we know it's fully divisible by 2, and only even numbers are fully divisible by 2. Hence, in that case, we increment count by 1, and that would essentially sense that count is in fact going to assume a value which would represent that we've sensed an even number. So if we don't sense an even number, we actually won't come inside this if statement, and count will never be incremented for that particular execution. Hence, we won't add to count. So essentially, we can then, of course, return count after it's all said and done and all the executions have sort of taken place. And we'll see what we got here. All greens. Awesome. Cool. So you'll see here, just for an example, let's just take a small one here. You'll see that we have so we were given as sort of a test case, right? We were given 2, 2, and 0, right? So they're expecting 3, obviously, because 2 plus 2 is in fact 3. But of course, they're all even numbers. So it said, okay, for the first iteration when I was 0, and of course these have indexes, right? So this is 0, this is 1, this is 2. The count of the indexes starts from 0. And so it says, okay, well, if for the first iteration, that is, where I is equal to 0, so we're at this particular element, the first element and the 0th index. So we say, okay, well, if nums I, which in this case would be nums of 0, modulus 2 is equal to 0, which it is, increment count by 1, and then of course we then sort of snap back to the beginning of the for loop, noting that I is still not less than nums.length, because nums.length is 3 and I is in fact 0 at the moment. And so then we increment I by 1, and so now we're suddenly looking at the second element in the array at the first index. In this case, we again evaluate whether that particular number divided by 2 has a remainder of 0, which of course it does, and so we increment count yet again by 1. And so then we add count, we add 1 to count. So by now, count is 2. Because we had one even number before, one even number now, count is 2. And then of course, we don't return count yet because we snap back to the beginning of the for loop and evaluate if in fact I is now less than nums.length, which in this case, since I is 2 on the second iteration, and of course the length is 3, I is less than nums.length. So we're actually not less than nums.length. So we're going to have one more execution, perhaps. So then, of course, we increment I by 1, and then we check whether or not. Actually, we don't increment I by 1. We just instead enter the body of the for loop, and we check whether or not nums I is sort of if nums I, which in this case is 2, which would reference the third element, which is 0, divided by 2 equals 0, or has a remainder of 0, which in this case it does, we increment count by 1, and of course then we snap back to the beginning of the for loop. So at this point, count is actually equal to 3, which is of course exactly what we'd expect. Then we evaluate whether or not we're at the end of the for loop, or rather, whether or not I is less than nums.length. So at this point, I is 2, and it is in fact less than nums.length. So when we come back to the beginning of the for loop, we increment I by 1, and so now I is essentially 4. So now I is not less than nums.length, and so or I would be equal to 3, and so that means I would be not less than nums.length, but actually equal to 3. And so in that case, we wouldn't execute what's inside the for loop, and we just return what we had, which was a count of 3. And so that's how we sort of solve that question there.